Hello everyone. Today let's solve the problem Sereja and brackets. Right. So you can read the entire problem. They have clearly mentioned the problem statement along with the input and output. Also they have given the examples such that for this particular input we have to get this. We have to get the desired output. Nothing but this one. So also they have given note. You can clearly read the entire problem statement. Right. So I'll just summarize this one so that it will be easy to understand. So just give me a second. Yes, something is wrong with my system. Just give me a second. So yeah. So what the question states here, we are given a sequence of brackets. So we are given a sequence of brackets. Yes. So we are given a sequence of brackets. Yes. Containing this one, opening braces and closing braces, this one, common brackets, right? So we have given a sequence of braces. Either it has to be opening braces, this one, or the closing bracket, this one, and m queries. So we are given a sequence of brackets, the common bracket, this one, opening or the closing bracket, along with the m queries. So each query provides a range li, ri. So each query provides the range li or I. This has to be in the range li, ri, nothing but l, r, and ask for the length of the longest valid bracket subsequence in that range. Within this range, we have to determine the longest valid bracket subsequence. Longest valid bracket subsequence, right? This is what we have to determine. So a valid bracket subsequence is one where every opening bracket has a corresponding closing bracket. So so they have clearly mentioned that for every opening braces we should have the closing bracket, and they have to be properly nested as well. So this has to be properly nested as well. So in this way, this has to be properly nested. Our task is to answer all the queries efficiently. So we have to answer all the queries efficiently. So I hope the question is clear. So I'll just delete this one. Let's discuss the approach. So first, what we will be doing, we will go with the input reading as usual. First step is always input reading, right? Input reading or the input handling. Here, as we are going with the Node.js, this completely belongs to this one, input handling and the reading side. We'll be going with the Node.js or the JavaScript here. And second step, let's come to the core logic. Nothing but here we'll be making use of the segment tree. So the approach that we'll be going with for this particular problem is segment tree. So why we'll be making use of the segment tree? Let's discuss the same thing here. So in the second step, after the input reading, we'll go with the segment tree construction. Why? Because we are able to process the string using the segment tree. So we are able to process the string using the segment tree to handle multiple range queries efficiently. So we can handle the multiple range queries efficiently using the segment tree. So range sum queries usually are solved with the one is segment tree or the sparse table or Fenwick tree or binary index tree. The same thing we'll call for the Fenwick tree, right? This thing. So we can handle the multiple range queries efficiently using the segment tree. So we'll be going with the segment tree. We are able to process the string using the segment tree as well, right? So for that purpose, for each query, the segment tree will help us calculate how many valid brackets subsequences can be found within the particular range. So in the segment tree, as we know that we'll be going with the build and update mainly, right? Then within particular range, either we can go for the sum or anything, any particular thing that is asked in the question. Build and update along with the range. This is common in the segment tree, right? So main thing is for each query, the tree helps us to calculate how many valid bracket subsequences can be found within that particular range. That is the reason we'll be going with the segment tree. So I'll just write here segment tree construction. This is segment tree construction in the second step. So after the segment tree construction, let's go with the third step. Nothing but we have to execute the query, right? Here, what we will do, here the tree will help us calculate how many valid bracket subsequence that can be formed within a particular range in the second step. After that one, we have to execute the queries, right? For each query, we will be traversing the segment tree to count the valid subsequences in the given range. In the third step, we have to calculate for the each query. We have to execute for the each query, right? So for each query, we will traverse the segment tree to count the valid subsequences in the given range. Nothing but here, I'll just mention this one as query execution. So here, what we are doing, for each query, we will traverse the segment tree to count the valid subsequences in the particular given range. And then we will update, right? Update and optimize. Here, the fourth step will be optimization. Nothing but we'll be making use of the segment tree, ensuring that we can answer each query in logarithmic time, making the solution sufficient even for the large inputs. Nothing but here, this is optimization. So what we are ensuring? We are ensuring that we can answer each query in the logarithmic time or log time. So making the solution efficient even for the large inputs. So here, this is nothing but the optimization. This one will be optimization. So fourth step. Finally, we will be getting the output in the third and fourth step. So we have to display the output or output the result. So in this case, we'll be making use of the console log. As we are making use of the JavaScript or Node, we can just make use of the console log and output and print the result. So here, I'll just mention this one as output. So I'll just mention this one as out. So this is the whole approach. We'll be going with the problem. So let's start writing the code so that you will get to know the problem correctly or correctly. So first step is we will import the FS module, right? Why we'll import the FS module? Because we have to read the input and do other stuff, right? So for that purpose. So I'll just give const fs equals require fs file system. So I'll just give here, let's make use of input. We have to read this one. So I'll just give read file sync. Just give me a second. So here we will go with, initially we'll go with 0 and set the encoding to UTF-8. So this is fine. Then after this, we have to remove the unnecessary spaces. So I'll just be making use of trim. So also we have to read each line of the input, right? For that, I'll just be making use of split and /n. So I hope this is clear. Then next, let's initialize the variables that is required. So here, at each step, we will be, we have to compute the values, right? And we have to update. So I'll be going with segment A, segment B, and segment C. Also, N, L, and answer. So we have to store the result as well. I'll be going with the ANS or the answer. So I'll just come here. Let me initialize with L, segment A, segment B, segment C, also L and answer. This is fine. Next, let's write the function to build the segment tree. So I'll just go with the function rather than class here this time. Let's write this way, function build. Let's initialize the leaf nodes of the segment tree. Initially, we have to initialize the leaf nodes of the particular segment tree, right? So it will be, build will be the same for all this thing, right? Where we are making use of the segment tree most of the times. It will be I less than 2 into n, then we will increment the I. So if L of within the array I minus n, then if it is equal to opening braces, then what we will do, we will be storing the opening braces, that is, we'll be storing the opening braces count in segment B. So let's make use of segment B here. Iterated value of the segment B, we will set this one to initially 1. Also, else what we will do, if it is closing bracket. Now, initially we have went with this one here, opening braces. Now, we'll go with the closing braces, right? Else, if I'll just take here directly, if possible, yeah, I'll just go with the else. Just give me a second here. My control set. Else if here I can write in this way. Love I minus n. This one, if it is equal to the closing common braces, then let's set the segment C to 1. Nothing but we'll be storing the closing bracket counts in the segment C. Iterated value of the segment C. Here we will be initializing this one to 1 initially. So this is fine. Next, after build, we will build the segment tree from the leaves upwards, right? Always we will mostly while making use of the segment tree, we will build the segment tree from the leaves upwards itself, if you have observed. So I'll just come here. Let's go like this. Let I equals n minus 1. I has to be greater than 0. Reverse iteration. N minus 1 greater than 0, n minus minus. So this is fine. After this, we have to find the minimum of left and right child. So to find the minimum of left and right child in the tree, we can directly go with the math.min, right? So I'll just, for the minimum, I'll just go min, or I'll just go with mi. So here, I'll just make use of math.min. We have made use of segment B and segment C to store, right? So in this case, it will be segment B. We have 2, so that's why it is 2 into I. Values, again, here it will be 2 into I plus 1. So I hope this is clear. After finding the minimum of left and right child, we have to calculate the valid sequences. Also, we have to display remaining opening braces along with the remaining close braces. These 3 things we have to do. First thing is we have to calculate the valid sequences. So here I'll just give segment A, nothing but iterated value of the segment A. Here it will be segment A of 2 into I plus segment A of 2 into I plus 1, also along with the minimum. So here this is fine. Here we are calculating the valid sequences. First was for the segment A. Then we have to calculate the remaining opening braces as well as the closing braces. This is same thing, but we have to change this one, right? We have to change for segment B and segment C. For the opening and closing braces, clearly you can see here in this step, we'll be making use of segment B and segment C. You have to be cautious with this, right? So I'll just copy this line and let me just change the variable names. So this has to be, just come here. Let me change this one to B, the last one to C here. This is nothing but, here also I'll just change this one to B, C. Let me come here and change this one to B. Here also, this will be C. So I hope this is clear. This is same, right? So next step, what we will do, we will write the function to process the each query. So we have to process each query and we have to update the value, right? So we have to get the result from the segment tree. For that purpose, we will be writing the function to process each query. So I'll just name the function name query itself here. So naming convention has to be good, right? So this will be left and right. So I'll just take the parameters left and right. Left, so let's adjust the indices for one based input. I'll just give for left, this will be left plus n minus 1. Next, I'll just give right, this one, right plus n minus 1. Next step, let's declare the variables to store the results from left and right sides of the tree. So I'll just consider here P1 and P2. You can consider anything. In my case, I'll just take P1 and P2 variables. So here, P1 we have three, right? One is left and right. P1, query 1, I'll just take this one as Q1 and also R1. Same goes with P2, Q2 and R2. I'll just initialize this one to 0. P1 equals 0. Also Q1 equals 0. R1 also, I'll set this one to 0. Here, same thing, let me copy here. And let me change this one to 2, right? So let me paste over here. This has to be 2, 2, 2. So this is fine. After this one, what we will do? We have to traverse the segment tree to get the result within the range or for the particular range. So in this case, left has to be less than or equal to right. So I'll just go with the while loop. While I can just write in this way, left less than or equal to right. So this is one thing. Next, let's check with the if it is odd or even. So means if left is odd, then we will be processing the current node. If right is even, then we will process the current node. That is the step we'll be doing here. For this, I'll just make use of the if condition. I can directly give if left module 2, this is equal to 1, nothing but odd. If it is odd, then minimum. How can we calculate? We can just make use of the math.min. We had done in the first step similar thing, right? We'll be knowing this one by now. This one will be Q1 segment C. We are using segment C for the left, right? So also these things, first one is P1 equals P1 plus segment A of this has to be left plus minimum. Same goes with, let me copy the same thing twice and make the necessary changes here, variable name, right? So I'll just give here V, also this one. So here, this has to be Q1 segment A instead of segment B. This has to be, this will be left itself. Instead of plus, I'll be making use of minus. Here also I'll be making use of minus. Here this will be instead of segment A, this will be segment C. This will remain as left itself. Here instead of Q1, it will be R1. I hope this is clear. Next, we have to increment the left after finding the minimum. So for incrementing the left, I'll just keep left plus plus. So if it is even, then I can just write if, right, we have to calculate for right. Right module 2, this is equal to 0, means E1. Then again, the same steps. I'll just consider this one and make the necessary changes. So I'll just copy the same things over here. So let me copy this one over here. So this has to be P2, Q2, R2. First thing, this will be same. Segment A, B and C. Instead of left here, just give me a second. Alt works here. I don't know. Let me check. Oh, it doesn't work, right? So just let me change this one to right. Right. Also this one to right as well. So this will be plus, minus, minus. This will be same. Also here, instead of incrementing the left, we are decrementing the right. So I'll just change this one to right minus. So I hope this is clear. After this step, let's move to the next level of the tree. Nothing but left here. We'll move the left part, this one to the next level. Also, we will move to the next level of the tree for right, this one as well, right? Right node as well. So how can I write this one? I can just give left equals 1. Also, right equals 1. So this is fine. Let's combine the results from both sides. I can just give to calculate the minimum. I'll be making use of the math.minimum. Nothing but we are combining the results from the both sides, left and right. So I can just give here Q1 and Q2, query 1 and query 2. So here result, I'll just take the variable name result 1. Let me take. This will be P1 plus P2. Also, we have to minimum mi I have taken, right? So this is fine. After this, we have to store the result, right? Somewhere we have to store the result. Nothing but we will multiply by 2 because each valid subsequence contains 2 brackets, nothing but opening braces and the closing braces. So we have to store this one somewhere. So I'll just make use of push. We have to add the result, right? So we are multiplying this one by 2 because it consists of the 2 braces. One is nothing but opening braces and the closing braces. I'll just give 2 into result 1. So this is fair. Next, let's write the main function to handle input and output. So I'll just make use of the function solve, or main, you can make use of anything. Here let me make use of solve itself. In the previous problem also I had made use of solve itself, right? So initial step is the bracket sequence. So here the bracket sequence will be, initially we'll start with the opening braces, right? That will be of the input, first input, this one here. And let's remove the unnecessary spaces using trim. The length of the sequence, let's mention the length of the sequence here, nothing but L dot none. So now we will declare the segment tree for the valid sequences. Nothing but first one, segment tree for the valid sequences. We have to initialize this one. We are declaring the array for the, we are declaring array of size 2 into n, and we are filling this one with 0. Nothing but segment tree for valid sequences, segment tree for the opening braces counts, also segment tree for the closing bracket counts. So for these things, so this will be segment A, segment B, and segment C, right? And let me write segment A and copy the same thing for segment B and segment C. So this will be 2 into n. Let me fill this one with 0. The same thing goes with segment tree for this one, opening bracket counts, and also segment tree for closing bracket counts. So let me copy this one for now. Just give me a second. So here this has to be segment B and this has to be segment C. So this is fine. So after this, let's build the segment tree. I'll just call build over here. So this is fine. Next, we have to store the results for the each query, right? For that, I'll just be initializing the result, or I'll just make use of ANS, nothing but the answer. We'll just initialize this one with the empty square braces, empty array, we can say. So we have to process the number of queries. For that, I'll just give let q equals, let's make use of the passing, convert this thing to integer, input of 1. So this is fine. Let's make use of the for loop. After initialization, let's go with the iteration. This will be I less than 2, I equals 2 minus 2 plus q. Sorry, this has to be 2 plus q, right? Let's increment the I. So next, let's read the query. So we have we can read the queries from we have left and right nodes, right? So we have to read the queries. I'll just consider here left and right. Let's consider the destructuring operator instead of initializing one left and right differently. So I'll just iterated value of the I. This will be also for the if there are distinct numbers of the if there are distinct numbers, then we should have the space between them to read, right? So for that one, I'll be making use of split. Also here it will be of, we'll be mapping of type number. This will be of the type number. The input will be of the type number. So that is the reason I'll be making use of number. So if we are dealing with the very large inputs or the large number, we can go with the big int. In my case, I'll be making use of number. If I get the output wrong, suppose there is a change in the output, like the last 2 numbers or the last 3 numbers, if there is change in last 2 or last 3 digits, then let's try with the big int, right? So after reading the query, we have to process each query, nothing but left and right. So here we have written the query this thing function already. So it will be of query left and right. So this is fine. Next, what I need to do after this, so we have to print the result, nothing but output the results for all the queries. We have got answer for the every individual query. We have to output the results for all the queries, right? So I'll be making use of console log to print, and we have already got the answer in the ANS, right? So let's join this one. As we have made use of the split, let's join, and we need the output and individual lines. So I'll just make use of /n here. So after this, what I'll do, let's make use of solve right here. Let's call the function solve over here. So I hope this is clear. So this is it. Somewhere I have missed the bracket actually. So let's see what I have done wrong here. So here I have done one thing, one mistake. Basically, I have added the extra braces here at the last while typing, I think. I have made this typo, except this, I think this has to work. Let's see. I'll just copy this one, copy the input, and we have to get this output, right? 002 10 4 6. So 002. Oh, let's run this one. Here, line number 57. Window and .fill is not a constructor we are getting, right? So we have made something wrong here. Let's come to line number 57 here. This has to be, just give me a second here. So this has to be new. We are initializing the array, right? Didn't I type array here? This is fine. Let me give array here. So yeah, let me run this one again. Reference error, segment is not defined. We have went with segment A, B and C. Seg A, seg B, seg C. So here in the line number 16, let's see. There is no segment variable. Yeah, this is fine. Here, this one, right? So just give me a second here. Where I have done the mistake? For loop in the function bin, right? Just give me a second here. This has to be segment B and segment C. While typing, I did type, I think. I don't know. This is fine. We are making use of segment B and segment C over here. You can clearly see segment B as well as segment C here. These two things. So we are calculating same thing, right? So let me run this one again. Here also reference error, cannot access MI before initialization. Did I? So let's come to line number 39. Let's see here. Didn't I initialize MI here? Let MI I have initialized here, right? So what's the problem here? Just give me a. So yeah, here what I have done here is this has to be capital M, math.min, right? So while initializing the MI, so I have considered small m actually. This has to be capital M. Let me run this one again. So again, we are getting the same thing, right? Cannot access MI before initialization. So we are not accessing MI before initialization. This is it. This one, line number 30. And so, did I miss something here? This is bracket or something. So yeah, what this is saying here is, we have initialized MI in this scope actually. But here this is different if this condition different, this scope is different, and we have to initialize the MI again, right? I have not initialized the MI here. So let me initialize this one. So this has to be at MI, nothing but the minimum. I'll just make use of math.min of, we are making here segment B, nothing but right, segment B of right, and R2 we have to go with, right? So this is, I hope this works. Let's see. Let me click on the run. So yeah, now we are getting the output, right? So let's check whether the output matches or not. So 00, 210, 4, 6. So here 00, 228, 6. So the output that we are getting here is wrong. So let's see what is the mistake that I have done. Here this has to be initialization in the line number 4. This has to be segment B. So I have given this one wrong, right? Let's run this one again. So again we are getting the same output, right? So why this is happening? Let's see. Let's check. Let's debug what. So let's check this one line by line. So here, just give me a second. Let's come to this one here. Yeah, here I have missed let, right? So in the line number 7, this has to be, I had missed let. This is fine. Still it gives the same, this thing. Let me come here. Calculate. This one has to be just give me a second. Yeah, here and this line number 18 and 19, this has to be minus actually, not plus. So this is one thing. Let me run this one again. Now we are getting 00, 210, 4, 6, 6. 00, 210, 4, 6, 6. So yeah, now we are getting the output correct, right? So many typos. So basically this has to be minus, and also here I missed something here. Yeah, here segment B I had given SEWB, and also here this one was wrong, right? So let I had missed. So these things. This is fine. Now this is working correctly, right? Let me run this one again. Yeah. Now this works correctly. Just give me a second. So I'll just come here. Let me click on submit code. So this has to be Sereja and brackets, right? I'll just paste this one. Let me paste this one and let me hit on submit. So this is giving us wrong answer on test 2, right? So let's check what is wrong. So here in the line number 49, we are getting the minimum value from Q1 and Q2. This has to be Q1 and R2, not Q1 and Q2. So this is one thing. I hope this will work correctly now. 00, 210, 4, 6. This is fine itself, right? The output that we were getting correct itself, but here this calculation was wrong. This and this line number 49, right? Here we have to get the minimum value from basically Q1 and R2, not Q2. So let me just give me a second here. I'll come here. Let me change this one. Yeah, this was C itself. I remove this one. We paste the new code. Let me hit the submit. So let's wait for some time. I hope this works this time. Yeah. So yeah, here you can clearly see this got accepted, right? So what were the wrong things here? Mainly in the line number 49, I'll just come here. This was like we were getting the minimum value from Q1 and Q2. This has to be Q1 and R2. This is one thing. And here this has to be minus, not plus here in this one. Line number 18 and 19. This was one more thing that was wrong. And here the segment, it has to be SEGB. I misspelled this one, SEWB. So I have changed this one to SEGB. Now also one more thing, there was wrong somewhere here. Yeah, I had missed let this one here in the line number 7, right? So these were the wrong things. I have corrected the code. Now this is working perfectly all right. We are getting the correct solution, right? This got accepted here. So this code works absolutely correct. So this is it. Thanks for watching, guys.